Welcome to Project Liberty Light, a multi-part build where we combine electronics, embedded systems, and a bit of creative storytelling to create something truly unique, a living, interactive American flag. This project is inspired by a milestone moment in history. With the 250th anniversary of the United States approaching this July 4th, there's no better time to build something that celebrates where we've been and how far we've come. Over the course of this series, we'll build a system that visually recreates historical American flag designs using LEDs, responds to user input through buttons and switches, plays patriotic audio to enhance the experience, evolves from a simple circuit into a polished, interactive display. While this build begins as a tribute to the celebration of the United States' birthday this year, a milestone moment of 250 years, this design is meant to live far beyond it. Whether it's Independence Day, Memorial Day, Veterans Day, or any moment worth recognizing, this living flag can be brought out year after year, continuing to tell the story one light at a time. This is part one of the series, Lighting the Foundation, where we take the first steps of bringing this living flag to life. If you're as interested as I am in creating this neat project, you're going to need the following items. An Arduino Uno R3 with USB cable. I'm using an Elegoo brand Arduino Uno R3. You'll need a solderless breadboard, some jumper wires, alligator jumper wires, two WS2812B 8x8 LED matrices, one 330 ohm resistor, a 1000 microfarad electrolytic capacitor, and of course you're going to need a computer and the Arduino IDE downloaded to your computer. As this series progresses, we'll add a few other items as we go, but for now, that's all we need. Every great system starts with a solid foundation. In this part, we're focusing on the visual core of the project, building a 16x8 LED display using two WS2812B matrices, powering the system safely and reliably, creating our first working flag representation, and laying the groundwork for everything that follows. By the end of this section, you won't just have blinking LEDs, you'll have the beginnings of a digital canvas ready to bring history to life. For step one of this part of the series, we're going to wire the LED matrices. I'm using two WS2812B 8x8 matrices to connect together to create one large 16x8 display. Each 8x8 WS2812B matrix has an input side where the start of data flow occurs. There's a green wire, or the DN, for data in. There's a white wire for ground, and a red wire for 5 volts. There's an output side, which is the end of data flow. There's also a green wire for it, for D out, or data out. There's a white wire for ground, and a red wire for 5 volts. And there's also two center wires for power injection. There's a red wire for 5 volts and a black wire for ground. The center wires are extra power inputs, which are very helpful. As for the step-by-step wiring, our goal is to chain the matrix wires together. We want the Arduino connected to the matrix 1 and matrix 1 connected to matrix 2. To do this, we'll make the following connections. For matrix 1, which I'm considering the left panel, we have the data part for matrix 1, where we'll have pin 6 of the Arduino go to a 330 ohm resistor, and from that resistor, we'll make a connection to the DN pin of matrix 1, or the green wire. We'll have a power connection from the red and white wire that are with that green wire to go to the 5 volt power supply. That'll be for the red wire, and the white wire will go to the ground power supply. And we also have two center wires at the back of the matrix board. That's the red and black wire, and the red wire will also go to the 5 volt power supply, and the black wire will also go to ground on the power supply. Moving on to matrix 2, or what I'm considering the right side panel, or the right panel. Its data connection is going to be where we take the green wire from the DN side of the board, and we want to connect it directly to the green wire, or the D out wire from matrix 1. The D out of matrix 2 does not need to go anywhere. It's just going to be an unused output. So we'll just put it off to the side for now. We're not going to make any connections to the D out of matrix 2. As for the power to the circuit, we're going to use a 5 volt, 5 amp power supply adapter to power our circuit, but that'll be later on. As for the initial prototyping stage that we're currently in, we're just going to power our circuit with the USB cable to the Arduino Uno coming from our computer at first as we're going through the code and initially setting up our circuit. But later on in the series, we will be using a 5 volt, 5 amp power supply adapter. So the power distribution plan for when we do use a power adapter later in the build will be to have the power supply go to the breadboard rails still during the prototype phase. So we'll have the 5 volts go to the positive power rail, ground go to the negative power rail, and then we'll place a 1000 microfarad electrolytic capacitor across the 5 volts and ground. To power the LED matrices from the power rails of the breadboard, we'll connect the 5 volts, all the red wires on both matrices will go to 5 volts, and then all the white and black wires will go get connected to ground. This is the biggest load, and we need to give it direct power. To power the Arduino, we'll use its 5 volt pin, not the barrel jack port, to connect to the positive rail of the breadboard, and we'll connect one of the ground pins of the Arduino to the negative rail of the breadboard. To power both matrices, we'll perform the following steps. For matrix 2, we'll connect the red input side to the 5 volt power supply. We'll connect the white input side to ground or to the ground of the power supply. We do not connect D out of matrix 2 back to the Arduino, so we don't want to connect it to power or ground, and we don't want to loop it back to matrix 1. This would cause problems or unpredictable behavior. Remember, we're going to leave D out of matrix 2 unconnected. And also, for the center wires, the red and black center wires on the back side of the LED matrix boards, we want to connect the red wires to 5 volts and the black wires to ground. To power both matrices, we need the 5 volt supply. Both matrices, the red wires and the center red wires, they need to go to the 5 volt supply. For both matrices, the white and black wires need to go to ground, and we need the Arduino ground to go to the same common ground. So we need to be sure that we're going over some very important rules here. We need a common ground, which means that the Arduino ground, the power supply ground, and both matrices grounds are all connected together. We do not daisy chain the power. We do not rely on matrix 1 to power matrix 2. Each matrix should get power directly from the supply. Data flows in one direction. The Arduino goes to DN of matrix 1. The D out of matrix 1 goes to DN of matrix 2. And never connect D out back to the Arduino. Here I'm connecting an orange jumper wire to the red wire of the DN connector of matrix 1, and a white wire to the white wire of the DN connector of matrix 1. This is so that I can connect the 5-volt supply and ground to the matrix by placing the orange jumper wire at a point on the positive rail of the breadboard and the white jumper wire at a negative point on the power rail of the breadboard. We also add protection components. We have a 330 ohm resistor that goes between the Arduino pin and DN of matrix 1, and we place a 1000 microfarad capacitor across the 5-volt and ground coming from the power supply, preferably near the matrices. Here I'm connecting a blue jumper wire to bridge between the cathode leg of the capacitor to a point on the adjacent negative power rail. Next, I place a yellow jumper wire at a point in line with the anode leg of the capacitor to connect it to a point on the adjacent positive power rail of the breadboard. Later, I'll add a couple of jumper wires to bridge the positive rails and the negative rails on either side of the breadboard to distribute both the 5-volt supply and common ground reference. Now I'm just adding a yellow jumper wire to the 5-volt pin of the Arduino to connect it to a point on the positive rail of the breadboard near the capacitor I just added. I'll then connect a white jumper wire from a ground pin on the Arduino to a point on the negative power rail of the breadboard near the capacitor I just added. These connections will act as our incoming power supply for now when I have the Arduino plugged into my computer later via the USB cable. These connections are only temporary during this initial stage of the build, again since we will be using a 5-volt, 5-amp power adapter as the supply later in the build series for this project. Now all there's left to do is to continue the connections for power and ground from the matrices to the power rails of the breadboard. I'll take a yellow jumper wire and place it into a point on the positive power rail. I'll take the white jumper wire and place it into a point on the negative power rail. I'll be using a red and white alligator clip jumper wire to connect each red and black center wires from both matrices to the yellow and white jumper wires I just connected at the breadboard power rails. Each red center wire from both matrices are grouped together with one end of the red alligator jumper, and the other end of this jumper will be clamped to the yellow jumper wire I placed into the positive power rail of the breadboard. And then each black center wire from both matrices are grouped together with one end of the white alligator jumper, and the other end of this jumper will be clamped to the white jumper wire I just placed into the negative power rail of the breadboard. Again, just as a reminder, we are not connecting the D out of matrix 2 to anything. For now, I'm just leaving it as is, but we'll have to neatly tuck it away somewhere later in the build process. I just won't worry about it right now. Now that we have the circuit together, we'll need to create the code, then upload the code to the Arduino. But first, we'll need to install a library we'll need for our code. In your Arduino IDE, you'll need to install the FastLED library. I'm currently using Arduino IDE 2.3.8, so I navigated to Sketch, Include Library, and then Manage Libraries. In the Library Manager, I searched FastLED. I chose FastLED by Daniel Garcia and clicked Install. After clicking the Install button, the FastLED library should install in your Arduino IDE. To use the FastLED library and code, you'll include it at the top of your sketch. Next, we'll want to test the code or just do a basic test. First, make sure that you are connected to your board and are using the correct port for your Arduino Uno. To do this, at the top of the Arduino IDE, click on Tools, Board, and then Arduino AVR boards, and then choose Arduino Uno. We'll have to go back to Tools again, then choose Port, and then choose your port. In this case, my port was called COM7 for the Arduino Uno. So once we load the code, compile it, and then upload it to the Arduino, what we should see are both panels light up together. The colors change every 2 seconds, and there should be no flickering or random colors. If something looks wrong, there may be the issue of only one panel lights up. What you'll need to do is maybe you need to check D out to the DN connections. And if you have an issue with flickering, you may need to check your ground connections or add a capacitor if you forgot to add it earlier across the incoming 5 volts and ground from the power supply. If you're getting the wrong colors, you may want to try changing GRB to RGB in the code. Now we want to create our 16 by 8 mapping. This is an important step. We will treat both panels as one screen. So what we'll need to do is add the getIndex function to our code, and then we want to replace the loop as you see here. And you can get this code directly from the website for the Project Liberty Light Part 1. I'll leave the link to that down in the description of this video so you can find it easily. And once you update your code and compile it and upload it to your Arduino, what you should see are red and white stripes, a blue canton on the top left corner of the matrices, and it should look like a simplified American flag. So there you have it. We have successfully been able to make our 16 by 8 matrices display a simplified version of the American flag. I think it looks great. I hope you were able to achieve this for yourself. If you need an explanation of the code, there is a detailed explanation for it at the website for this particular article for part 1 of this series, Lighting the Foundation for the Project Liberty Light, the Living Flag project. I'll leave a link down in the description of this video for that, along with other important information that you may need to successfully achieve this part of the project. At this point, your circuit is doing something pretty incredible. It's lighting up the American flag. What started as 2 separate LED matrices is now functioning as a single unified display capable of representing a recognizable American flag using nothing more than timing, logic, and a bit of code. Although the flag is currently separated into 2 pieces at the moment, it's still making its way to a digital canvas. Don't worry, it'll look great by the time we're through. At this point, we've wired and powered a multi-panel LED system, and we've created our first working flag representation in code. Up next in part 2 of this series, we're going to bring control to life. We'll start turning inputs into action and give ourselves direct control over what our system does. This is where it'll start to feel like a real embedded system. From here on out, we're not just lighting LEDs, we're building behavior. So I hope you join me next time for part 2. I really hope that you enjoyed this part of the project and stick around for the rest. Again, thank you for joining me. I'll see you on the next one, and remember to keep at it and stay motivated.